Here's another example of solving a system of equations with two variables. And in this case, it's a mixture problem. And these come up in lots of situations where you have, in this case, you're in chemistry, and you have one solution that is a weak solution of acid, and it's only 10% acid. And you want to mix it with a stronger solution, solution 2, that's 50% acid. And your goal when you mix those two things is to come up with something that's in the middle, or in between 10% and 50%, and I want it to be 25%. And if you think about it, if I had the same amount of the weak acid and the strong acid, my percentages is just going to average. So the average of 10 and 50 is 30. So I want a little bit weaker acid, so I'm going to end up having more of the 10% and a little bit less of the 50%, more of the weak and a little bit less of the strong. But how do you calculate exactly how much of each you'd have? You set up a system of equations. And so in this case, we're going to have two variables. One is x liters of the first amount, and we're going to have y liters of the second solution, and they tell us we want 2 liters when we're all done. Okay, so that's one equation. That's the volume. And we're going to have another fact that's how much acid is in each one. And so I can set that up by the first x liters are 10% acid. So 10% times x gives me how much acid is in there. The second one is half acid, 50% times y. And I want to end up with 25% times 2. And so every one of these mixture problems, you're going to have a percent or a rate times the amount in the first, plus a rate times the amount in the second equals the rate of the mixture, all right? And once you set that up, it's often helpful to rewrite it in a way without all the units and rewrite it a little bit nicer in this green box. Just organize it a little bit. And then if we want to solve this, I'm going to rewrite each of these. I'm going to solve for y in that first equation, so I can do substitution. And I don't like those decimals. I mean, they're not bad, but I can get rid of them by multiplying by 10. By 10, and I just get x plus 5y equals 5. And there is an equivalent system of equations. I can now solve those two equations. And I can set it up by doing substitution, taking this 2 minus x and substituting it in. Then I only have x's in my equation. I can multiply things out, and I solve without too much trouble, and it's 5/4, 1.25 liters of the weaker solution, and that means the rest, 3/4 of a liter, of the strong solution. And so often you'll see these mixture problems, and I could have solved this by elimination just as well, but I chose substitution. There's no real, in this case, either one will work reasonably well.